Hello and welcome to our photo texturing workshop. Over the course of the next couple of hours, I'm going to show you how to go from a digital picture and a 3D mesh to a picture-perfect 3D model. As the name of the event implies, it will be dedicated to the new Artec Studio 16 feature that is used for photo texturing, which means we'll be able to apply externally taken pictures onto our meshes and therefore improve the quality of our texture pretty substantially. Okay, so here is a range of topics that we'll cover today. We are starting with the general introduction of the setups that we prepare for you, as well as the feature itself. We call this event a workshop for a reason, so we'll waste no time and go straight to practicing. Our first mission will be scanning and texturing a middle-sized item with the Leo. We'll use the scanner for geometry, but for texture, we'll use iPhone 12 Pro Max. Having processed this project, we will move on to our second setup and scan a small object with Artec Micro. This time around, we'll use a professional light box, and in general, we'll have a professional setup for this part of the webinar. Also, for texture, we'll use a DSLR camera instead of a mobile phone. We also prepared another setup, which I will not elaborate as of now, but we'll get to that in just a minute. Once it's all done, it will be time to discuss some do's and don'ts in photo texturing. There is quite a few of those. And also we'll give you some useful advanced tips on the algorithm. Apart from all that, we also prepared a comprehensive compilation of beautifully photo textured items from several different industries. So we'll share this with you. And the last bit of our webinar will be Q&A. So we suppose it's going to be an icing on the cake of the event, because during the Artec Studio 16 launch event, we got a lot of questions regarding photo texturing. So I'm just wondering what kind of questions we'll have today. All right, so to be able to process everything quickly with you online, we put together a fairly powerful computer right here. We've got Intel i9 processor, NVIDIA RTX 3060 graphic card, complemented by 128 gigs of RAM, if I'm not mistaken. Now, let me introduce to you our first scanning setup. Here, we are going to scan a middle-sized item with the Leo. But let's begin with the object. As you can see, we've got a beautifully textured 700mm tall ceramic vase, which has a very distinctive texture pattern full of fine details. The surface of the vase, I'm not sure if you can see it from that far, but the surface is fairly shiny and geometry is very much repetitive, which poses an additional challenge when scanning the item. Our goal for this project is to quickly scan it for geometry, then grab a smartphone to capture and preserve its texture features, and then import all the raw data into Artec Studio to go through every step of processing together with you online. When it comes to the scanner, Leo was a pretty obvious choice for us. As you probably know, currently in our product line, we've got 6 scanners. We've got Artec Micro, that is a high-precision stationary scanner. We also got Artec Ray, that is our long-range laser scanner. Neither of these would be suitable for the job due to the size of the item, obviously, for the most part. We also did not consider our third scanner, Artec Space Spider, either, mainly because, well, it's got great resolution, right? So technically it would be a good choice. But this object right here, since it hasn't got that many fine geometrical details, it wouldn't really allow us to unleash the full potential of the scanner. So that's why we did not really consider it. Artec Eva, which is our fourth product, it could be a good choice as well. It's got large field of view, which means we could scan the whole thing fairly quickly. And actually, that would be our second choice. Eva Lite, which is a simplified version of Eva, this scanner could not be used for the project because it's got all the texture-related functionality turned off. But if we update it to the full version, then yeah, we could use it for the job. And finally, Artec Leo. A perfect scanner for the job. It's got massive field of view. It's got HD mode, which would help us to reconstruct shiny stuff. And yeah, it's very mobile. It's got no wires, so nothing would be wrapping around the item as we scan it. This is why we selected. Okay, now let's move on to the second area. And like I said before, we've got our precision front runner Artec Micro here. We will certainly need all that high accuracy and resolution because our object today is quite something else. It is a tiny Warhammer figurine with complex geometry, lots of ridiculously small elements, and vibrant texture. So yeah, let's see if we can capture all that vibrancy and transfer it onto a highly detailed fusion of micro. To facilitate that, we equipped this scanning setup with a professional digital camera, as well as a professional light box, or as they're also called, photography studio tents. This studio tent is used for surrounding your object with light from 2 LED strips with diffusers, and eventually enable smooth illumination across the whole part. Okay, remember in the introduction I mentioned that we've got the third setup. The thing is, our scanning experts are constantly roaming the world in search for great new objects to scan, and now they're ended up at Formnext, which is a leading additive manufacturing fair. It so happens that this year Formnext takes place on the same date as our event, so we decided to connect to our colleagues in Germany and ask them to scan something fascinating for us, share it with us so we could share it with you. Let's see what they got.
To welcome everyone from Formnext event, the biggest manufacturing, additive manufacturing and industrial 3D scanning, where we showcase our 3D scanners and our new features of Artec Studio. We have very interesting workshops in our booth, like the phototexturing one, where we make photorealistic texture onto this model of this very colorful chair. So let's take a look on how to actually do that. So our photo editor is taking pictures of the chair with a professional camera. Once he's done, he'll move on to 3D scanning. Photos taken with the camera will be uploaded into Artec Studio and then mapped onto the 3D mesh captured with Artec Leo. After scanning and processing the scan, the model will be uploaded to Artec Cloud, where we will be able to share it with our colleagues. You can find these very interesting workshops at the booth 12.1 G111. So that's it for me, and see you next time.
Yeah, just like my colleagues mentioned, the project that they put together will be uploaded onto the Artec Cloud, shared with us, so I could share it with you. Okay, let's move on to the second section. If you ever scan anything with an Artec scanner, or maybe you check the models on a website, then you probably know that we can apply colors that our texture cameras capture to the meshes that we create. The quality of that texture is great, right? And it's good enough for the vast majority of the applications. That quality depends on the selection of the scanner, on the scanning distance, on the lighting conditions, and probably on the general scanning routine. Again, just like I said, for the majority of applications, the quality is more than enough, but in some industries, people strive for photorealistic texture, for incredible texture. I'm primarily talking about heritage preservation, CGI, science and education, product design, demonstration, and probably forensics as well. Professionals from these domains used to have two options, basically. The first and the most obvious option was photogrammetry. You might have heard about this technology because it's been around for quite a while. And it might sound like a pretty straightforward workflow to execute. Just snap a few pictures, process it through a photogrammetry software, and you get a textured mesh as a result. But when you start doing that, you face multiple limitations. Some use cases may require multiple cameras being assembled into a rig, which is both pricey and inconvenient. But the biggest limitation, arguably, has to do with resolution. If you want to be able to see fine geometrical details on your final mesh, then you will hardly be satisfied with what photogrammetry has to offer. So the bottom line of the technology is fantastic texture, but considerably poor geometry. In a reasonable attempt to improve the quality of your photo textured model, but the industry in general, the market, came up with a new solution. And this solution is option number 2. It tries to take the best from the both worlds, actually. It allows you to take pictures with an external camera and then apply that texture onto a model that you acquire through a 3D scanner. Again, sounds very promising, but to execute this workflow, one needs to go through several stages of processing while jumping from one piece of software to another. Not to mention that first you need to figure out how to use all that software, which is not an intuitive process by any means. The new photo texturing algorithm that we released is supposed to bridge that gap between highly detailed meshes that our scanners are capable of generating and fantastic photorealistic texture by allowing you to wrap these pictures around your model without leaving the Artec Studio environment. To facilitate that, we added a new type of elements that is supported by Artec Studio, which is pictures. So now we can import pictures. And also we had to add another registration algorithm, photo registration. We will elaborate on all of the steps of processing when working on our first project. But before we embark on our first scanning endeavor, let me quickly outline the main scanning principles. The majority of people watching, I believe, are experienced 3D scanning professionals, but we're also joined by a number of people that are fairly new to the industry. So I'd like to give them a little bit more context of what's going to be happening next. When we scan an object, basically we create a sequence of 3D surfaces and pictures, which we capture every second. We capture a certain number of them every second. Having connected all these surfaces together, given that we scanned everything thoroughly, as a result, we get a closed volume that represents the final shape of the object. The huge question here is how to align all of those frames, how to position them very precisely against each other. Some of the companies, the 3D scanning equipment producers, rely on external trackers to track the position of the scanner and use the coordinates for alignment. Others utilize targets. You might have seen the small circular things which are put either around the item or stuck to the item itself. Artec, in turn, employs a so-called hybrid tracking technology that utilizes inconsistencies of the object's shape and color for tracking and alignment. We call these inconsistencies features, texture and geometry features, and we always try to make sure we have as many of these in the field of view during scanning. We don't necessarily need both texture and geometry. We can get away with having either. So even this type of object, which is, as far as geometry is concerned, is fairly repetitive, right? But it's got great texture, which means we will have no issues scanning and tracking the object. The speed of data capturing of frames per second ratio and the size of the 3D surfaces that we acquire, that is controlled by the field of view of the scanner, they differ from scanner to scanner. We take these parameters into account when choosing the right scanner for the job and selecting the proper scanning speed. Okay, I believe this should be enough for the introduction. We will establish the rest of the important scanning principles as we begin working on our first project, which will happen just about now, actually. Let's switch to the second camera, where Dmitry is ready to scan the ceramic vase with the Leo. If you look closely, you will know that Dima is following a certain scanning path. And that scanning path he established before getting down to scanning. The thing is, trajectory plays a fundamental role in keeping your project within reasonable frame limits and also helps you to be confident that you captured all the necessary details. For this item, we utilize a spiral trajectory, which means we go around the object with the scanner and gradually move it along the vertical axis. And we do it in a way that every next circle around the object covers a new area and also overlaps with the previous one. Another important aspect is distance. This is something that you should definitely keep in mind. Both in Artec Studio and on the Leo screen, we can control distance through the use of the distance color map feature. The rule of the thumb here is, by default, we want to be in the green zone, somewhere close to the middle of the depth of field. If we aim to capture the finest details, we should consider scanning closer to the nearest border of the field of view. When we're done scanning, there are multiple different ways that we can go if we need to import data to a computer. So generally, we have four options. The first one is establishing direct Wi-Fi connection between the scanner and the computer. The second option is to place both devices into the same Wi-Fi network and send the files like that. Option number 3 is to use an SD card, memory card that is inserted into the Leo. And the last option, which we will use right now actually, is sending your files via the Ethernet cable. This is the quickest method, so we'll use it right now. Oh, by the way, technically there is another new method of data transporting, which is uploading it onto the Artec cloud and then downloading it on your computer. For this particular project, we won't use it for an obvious reason. However, for the setup in Germany that we just showed you, we'll do exactly that. Our colleagues will upload the data onto the Artec Studio, and I'll show it to you right here. I won't download it though. I'll use the Artec cloud to showcase the results. Okay, while Dima is doing all the import of the project, let's begin planning our next steps. Now we have acquired the geometry of the object, so it's time to establish some texturing rules and then to take some pictures. But before grabbing the camera, let's establish the basic rules of photographing for photo texturing. First and foremost, make sure the object has prominent texture features. The algorithm, as of now, doesn't rely on geometry, so that means that we need to have a very good texture on the item. If it's not the case and the texture is very poor, and for large objects with like large monochromatic areas, please consider adding additional features on the background to highlight the texture. Light obviously plays a great role here. When we use the algorithm, please provide adequate lighting. It is recommended to use external studio lighting like softboxes and not to use flash. Just like with photography in general, the better the lighting conditions are, the more you can expect from the algorithm, from photo texturing. And by the way, that doesn't necessarily mean that we cannot get impressive results without having a ton of professional equipment. Distance. The next very important aspect is distance. So when it comes to positioning and distance, the object must be at the center of the picture and occupy the most space. For proper registration, all photos must be of the same focal length and resolution, which means that focal length, exposure, and aperture need to be adjusted and fixed before you start taking pictures. Also, try not to rotate the camera. Instead, select either portrait or what's that second thing? Landscape mode. Yeah, choose either portrait or landscape modes, and use that mode for the entire photo session. Okay, now let's begin taking pictures of the vase and point out some more important aspects. Overlap. When moving the camera, we should establish a significant overlap between the shots. A 70% overlap is something you should aim for. To make sure we have enough info for registration, each element of the object should be photographed at least 3 times. Please avoid taking pictures of any additional object that can disturb the texture. And basically just take the pictures of the object that you're scanning and nothing else. Format. Although Artec Studio supports multiple different formats, it is recommended to convert your photos to JPEG format and that way preserve their EXIF information. You don't necessarily need to convert every other format into JPEG, but some of the formats, like the native iPhone RAW pictures format, cannot be imported as is, so we need to convert it. And for that conversion, please consider using the JPEG format. Correction. So when it comes to correction of your pictures, you can actually do that. You can correct color or white balance, and you can do that in the third-party software during post-processing. If you review your pictures and think they could use some improvement, feel free to modify them. But it is advisable to process all of the photos in the same manner. So please don't select just a couple of pictures, apply some filters, and leave the rest of the frames original. If you do apply some modifications, apply it to the entire photo shoot. And also, please avoid any geometrical transformations, resizing, and distortion corrections. Okay, moving on to the next point, which is white balance. When you move around the item, you might notice that some parts of the object look darker or brighter than on the other shots. And here you might be tempted to adjust white balance to your camera, and generally, we cannot recommend that. However, we had projects where we actually did it. It made texture look a bit better, and we sort of got away with it without getting any additional artifacts. So do it at your own risk, but please consider improving the lighting conditions instead as a means of fixing any texture-related problems. All right, once the pictures are taken, we won't need any additional tricks to send them to your computer. Just connect it with a wire or send it via Google Drive. It doesn't really matter. All right, so now as we have collected everything that we need, we've got scans for geometry, we've got pictures for texture. Let me briefly introduce to you the processing workflow. Everything will be done in Artec Studio, which is our software package for advanced 3D scanning and data processing. Today, we'll use it to transform our raw data into high-resolution 3D meshes and then apply texture to it. But if we needed to, we could also do some mesh modifications. We can do 3D compare maps. We can do some measurements. We could fit in primitives, maybe even freeforms, and that way facilitate reverse engineering. Okay, so when it comes to processing, here's the general sequence of events. We will begin with erasing everything that we do not need. Normally, when you scan an object, you inevitably capture some of the background or maybe some other items that happen to get into the field of view. And on that first step of processing, we will address that problem. We will erase everything we don't need. In some cases, we still need the background for registration, but in the general cases that we do not, so we erase the background. The second step is alignment. Having erased everything we don't need, we need to put our scans together. This step can be considered situational because in some projects, the entire geometry will be captured within just one scan, which means there is nothing to align. Like in our example right here, the vase that we'll be processing in just a second, we decided against capturing the very bottom of it because it hasn't got any interesting texture. So we captured the whole geometry within just one scanning session with just one scan, right? So we will technically be able to skip the step of alignment. The next step is arguably the most important one as it defines accuracy and resolution of your final mesh. We call this step global registration, and it is in charge of positioning every single frame in your project very precisely with respect to the rest of the frames. After that, we are ready to select one of the three types of the fusion algorithms that we have in Artec Studio and triangulate our raw data into a fine polygonal mesh. The polygonal count of our meshes can normally be reduced to a certain extent without losing the finest geometrical details. We call this step mesh simplification, and this is the last thing we'll need to do before moving on to texturing. Okay, once the model has been simplified, next up we import the pictures that we took and run photo registration. On that step, we position the pictures that we took around the mesh so that they can be properly projected onto the surface. And at the last step, once everything else is done, we apply texture to the model. It will take a minute for the algorithm to do the job. And after that, we'll be able to play with a couple of settings like brightness, saturation, hue, and a couple of other parameters if you feel like it can be used for the project. Okay, now let me switch to my screen. We've got everything ready. We are ready to start processing. All right, yeah, you should be able to see my screen now. So, just like I said, we've got one project. We use HD mode for this project, just in case. We've got 214 frames in the project, and we will begin with erasing everything that we do not need here. I will be doing that very quickly so that we don't waste too much time on processing. I'll go to eraser. We have multiple different geometry selection methods, but for the sake of time saving, I'll probably use lasso. Actually, you know what? I will run registration first. Yeah, I'll register my scan real quick. Global registration. I'll use 0.3 for KFR. Apply. Let's see what we get. A little bit easier to erase the background once all of the frames have been aligned precisely. Okay, it might take just a moment for the registration to complete. I use the KFR setting of 0.3, which is slightly above the default level, but it's not going to be a problem. I don't think it should take long because the computer is fairly powerful. So once I've done that, we will have all of our frames within the project perfectly aligned against each other. And I think later during processing, we'll be able to skip the global registration stage because we've already done that. Okay, so I have registered everything, and now we can finally erase everything more conveniently. I'll use lasso selection and do it like that. I know I've also selected some bits and pieces of the object itself, but for the sake of the demo, it doesn't really matter. Okay, so that is the object. As you probably remember, the next step is technically alignment, but there is nothing to align. We've only got one scan. And once alignment is done, or since we skip that step, we're ready to do global registration, which we have already done anyway. So now we can fuse our model. So we go to settings, tools pattern, sharp fusion, and yeah, we'll use 0.5 for resolution. This is an HD scan. If you check the error, it is 0.3, which means we can get away with the resolution of 0.5. For the standard definition scans, we would almost never go as high for a resolution. We'll probably stop at 0.8, maybe even 1. But for the HD, we can go as high as 0.3, and in some cases even 0.2. If the point density is high enough, then we can get away with this kind of resolution. But in this case, 0.5, I think it should be great. Again, might take a minute for the algorithm to complete. I expect to have from 5 to 8 million of polygons for object of this size and the resolution of 0.5. So let's see what Fusion has to offer. When we'll have the Fusion, we'll be ready to simplify the mesh. And the reason why we actually want to do that, it's not only because it will be easier to work with the mesh, but also texturing. Texturing will take less time if we reduce the polygon count of the mesh. All right. And by the way, for this project, I used Sharp Fusion, which we normally use as default, right? This is our default option, but we could also use Fast Fusion or Smooth Fusion. For these type of items, we could get away with using Smooth Fusion, I think, because there are no sharp edges to outline. But since Sharp Fusion is a default option, I think I'm going to stick to that. All right, so just one more second until we get the Fusion. By the way, the texture that you can see right now on the screen, it does not represent the quality of your final texture, right? This is merely the texture frames that we have captured during scanning. So these haven't been projected onto the mesh yet, and they do not really represent the quality of your final mesh. Okay, so this is what we got. This is the mesh. And let's see how many polygons it is made of. 6.8 mil. Okay. Let's simplify it to 800,000. That is a pretty serious simplification. I would normally simplify by about 50% first, but in this case, we don't really have tiny geometrical details to lose, and also I'm more interested in completing the workflow as quick as possible. So yeah, it's going to allow us to save up some time on texturing. So let's simplify to 800,000 polygons. Again, in Artec Studio, we have a selection of different simplification methods. Each of the methods is suitable for a particular situation. For example, this method is called fast mesh simplification, which allows us to specify the exact number of polygons which we want our mesh to be made of. But we've also got algorithms that allow you, for example, to select a particular deviation, right? And the algorithm will be simplifying your mesh up until the deviation reaches the outline number. So yeah, you can always experiment with different methods. You can also remesh your mesh entirely, which means all the polygons will be of exactly the same size. Okay, now the mesh has been simplified at 800,000 polygons, and it's time to import the pictures, right? Now, this is the stage where our photo texturing algorithms kick in. So import pictures. I've got the workshop folder prepared right here. And yeah, Dima's pictures are located right over here. I'm going to select all of them, click open. They're normally imported fairly quickly. But, okay, yeah, let's not get ahead of ourselves. All right, pictures have been imported. You can see a new data set added to the workspace, photos. So the next thing we do, we need to register these pictures. We need to position them around the mesh very precisely so that they can be projected onto the surface of the object and therefore apply all that nice texture. For that, we need to select the raw scan, the fusion, and the photo set, the photo set, I guess. We can, then we should go to Tools panel, select photo registration, and click Apply. As you might have noticed, there were a couple of settings to the algorithm. So now let's go over all of them and see what they do. In most cases, we can get away with using default settings, but sometimes you might want to change them depending on the project that you're working on. The first setting was pre-process images, and this setting helps you to get more contrasted pictures in case of dark texture. So you're supposed to turn it on when taking pictures from afar or when the texture of the object is rather dark. The second setting is describe a preset. It can be either high or normal. And this setting controls how the algorithm processes pictures. And the rule here is for objects with plenty of texture features, use high, and for the rest of the objects, stick to normal. So this setting defines how many pictures will be extracted, how many features will be extracted, but at the same time, all these features need to exist. So if you have really fine texture pattern on the object, then use high. If the texture is rather normal, then stick to the default option, which is normal. Camera field of view, this is the third setting. And this parameter you will need to change very rarely. Artec Studio determines this value automatically using photo metadata. So it checks your pictures and gets this number from there. But it cannot be, if it cannot be done for whatever reason automatically, you can specify it manually, right? And that data can be either found on the website of the producer of your camera, or there are also some calculators on the internet that can allow you to calculate your field of view. I think we're going to share the link to that resource later throughout the webinar. Yeah, so in case you need to specify that, you will be able to. But again, just like I said, it will be happening very rarely that you need to specify it manually. Normally, the reason for the metadata not to be taken from the pictures is conversion, or conversion, I'm not sure. So when you do that, when you change the format of your pictures, you can lose the EXIF data, and that way you won't be able to get it from the pictures. Yeah, so once the registration will be finished, just like with our scans in Artec Studio, we'll be able to assess the error. So a particular error parameter or error number will be assigned to the photo set that we used. The numbers that you will be getting, they vary from 0 to, I would say, to about 10. But if it reaches 10, then you've got a serious problem. Generally, the ranges that we prefer to operate within is from 0 to 3.5. If you've got the registration quality within those limits, then you should be okay with your final texture. If it falls into the category from 3.5 to about 5, then you are, I don't want to say likely, but the artifacts are more probable. So you might get some artifacts on your texture. You should be more careful with checking the quality of your texture. And if the error of your photo registration exceeds 5, then you are highly likely to have issues with texturing. Well, texturing will go just fine, but when you assess the quality of your texture, you'll probably see some misalignments. You might notice some blurry areas, or that some areas are actually darker than the other ones. If that happens, your best bet is to take some extra pictures, re-import the entire batch of pictures, so the new ones with the ones that you took previously, and and run another photo registration. That's what you do. Okay, photo registration is finished, and as you can see, our error parameter is 2.3, which is more than acceptable, which means we are ready to apply the texture. Okay, let's go to the texture tab. The important thing here is that we need to, for select texture source, we need to select the photos only. We don't select the texture of the original scans, right? Okay, export, in paint missing texture, 16K, that should be all right. Okay. Again, texturing will take a moment here. First, we need to map all the pictures, then to project them onto the mesh. Once it's all done, I think I will not use any corrections, although I could, because I want to compare what we get here against the original Leo's texture. And I've already got it, so I'll just import it into the Artec Studio, and we'll be able to compare these two textures against each other. Just like you will see in about a minute, Leo's texture isn't half bad. So technically, if you don't see photo texture, I don't think you will think that there is anything wrong with the texture from Leo. But once you've checked what the photo texturing has to offer, then yeah, everything else looks kind of inferior to that. So when we were capturing this object with the Leo, all the shots were taken from approximately the 500 millimeters distance, right? Including the texture pictures. And that probably explains the difference in the texture quality pretty well. Because when we were taking the photos of the object with a smartphone, we were at about 200 millimeters, I would say, from the object. So we captured all these fine details of the item, and we should be able to see it now on the final texture. There is a very interesting trick, which we'll talk about a bit later, but I'd like to mention that if you are dissatisfied with your texture, if you applied your pictures to your model and you can still see some blurry areas, or maybe you are dissatisfied with artifacts, you can always take some extra pics, and you can take them from a closer distance, and that way you can locally prove the quality of your final texture. We'll go we'll elaborate on that a bit later, but now I just want to let you know that if you're dissatisfied with the texture, there are different ways of fixing that. Okay, so now we are on the texture mapping stage. I selected a pretty high output texture size, which is 16K by 16K. For object of this size, I think we could use 8K by 8K without seeing any difference really, but okay, since we are particularly interested in the texture of the item, let's check the highest resolution. That resolution defines how well we'll be able to see all the fine and tiny elements on the final model, texture elements specifically, obviously, yeah, because it doesn't control geometry. We can also check the settings that I used. I used export mode, which is the default mode for texturing. And also I have in paint missing texture setting turned on, which means if there are any areas which we kind of missed or skipped with a texture camera, this area will be filled with the texture from the surrounding areas. So this algorithm evaluates the texture and evaluates the texture from the surrounding areas and kind of fills all the void with something that looks like the surrounding area. For this model, I don't think we'll have any of these areas at all, but just in case, let's select it. Again, I will touch on that a bit later, but here I made a point of us not selecting original scan for the source of texture together with the photo set. And that is because it normally brings no advantages. right? It's not particularly harmful either, so it will not mess up everything for you. But what you get as a result of that is normally just your regular Leo texture, no benefits from the pictures, and sometimes you might get some additional artifacts. So there is virtually no use for combining your scanner's texture with the texture from your pictures. Well, arguably the only benefit could be that if you missed a large area with a camera, then it will most definitely be covered on your original scans. But then again, it's probably easier to take a few more shots and re-import the texture, rerun registration, and reapply it than using both. Okay, and also in some cases you will need to import several different photo data sets. We'll go over that scenario in a minute. And if that's the case, then obviously you will need to select all of them here. So my point is you only select photos and you don't select scans for the source of texture. Okay, let's give the algorithm another minute. Oh, by the way, we can still see some geometry here, some geometrical pattern. Okay, but we simplified the model quite a bit. Probably prior to simplification, these features were more prominent, but we are not interested in them anyway. We will check the texture, we'll import the Leo's texture, and we'll see what is the difference exactly. One of the important things that you will be able to notice, oh, okay, let me get straight to the texture right here. Okay, so just like I said, we are technically able to change some settings. We can adjust brightness, saturation, hue, contrast, and gamma. But we won't do that. Let's keep it as is. Let's click apply. And before we get some close-ups, let me actually go ahead and import Leo's data. Okay, this is something that I pre-prepared. This is, yeah, this is basically the same project, but with the Leo's texture applied to the object. Okay, so this is what Leo has to offer. Again, if you don't see what photo texturing does, it won't look bad, right? It looks great. You get some overexposure here and there, but it's not half bad actually. It looks great. It looks great. All the texture patterns are clearly visible. Yeah, and we could also work on these areas as well because we've got the glare reduction algorithm in texturing. So yeah, technically, if you work with it, it might look good. But then you compare this against the photo textured model, and you can see how much more details are now available and just how much sharper your texture looks. Okay, let me go right here, for example. Maybe let me find like a nice area. Okay, I like this one. All right, so again, take a look. This is the photo textured model, and this is the model of the Leo. These tiny black spots, they are clearly visible on this texture, and they're sort of blurry right here. So yeah, this is basically what you get as a result. For this particular item, I'll probably adjust brightness a tiny bit. So you can always do that. You just right-click on your mesh, go to Adjust Texture, and decrease brightness. Apply. Okay, now it looks even more authentic. Yep. Okay, so this finalizes the project number 1. And this is what the photo texturing algorithm has to offer in that example. By the way, to texture that model, I think we acquired about 38 pictures, about 40 pictures, so not that many. And meanwhile, we already begun taking pictures over a second object in the lightbox. This time around, we started with taking pictures, and then we will move on to scanning. As you watch Dima going through the workflow again, I'd like to bring your attention to an extremely important part of the photo texturing pipeline, that is the background. The thing is, unless your object has plenty of sharp, distinctive texture features, you might want to use a texture-rich background. The problem here is that until you run photo registration and check its results, you don't really know if the features of your object are that great, which brings me to arguably the best piece of advice that I could potentially give you when it comes to the photo texturing algorithm. It is always put the item that you're scanning and photographing on something that has good texture. It can be anything from the morning newspaper to the Artec turntable. Please remember that printed text makes great texture features. The second essential point that I would like to make is that rotating tables should be used with caution. Unless you're using a light box like the one that we've got here, or surface behind the object is absolutely monochrome, you should be very careful with rotating tables. I know it might look very convenient to just attach your camera to a tripod, put the object on a rotating table, and then give that table a lazy spin every other second, accompanying it with occasional shutter clicking. But the issue here is that the background moves together with the object, which might pose extra challenges when it comes to the reconstruction of the camera position. So although all that data is outside of the depth of field of your camera, it may still tamper with the work of the algorithm. So with that said, your best bet is to put the item on some sort of a stand, which has nice background. Make sure you've got enough room around it, and then just walk around the item, around the stand with the scanner and the camera instead of rotating the object, right? So we rotate around the object instead of rotating the object itself. Things get a bit more interesting when we need to reposition the item and capture it from several different angles. We haven't mentioned that sort of scenario yet, and we didn't utilize it on our first model right here. So we discuss that a bit later, okay? We'll get back to that, and in one of the further sections of the webinar, we will talk about this sort of scenario. All right, with this project, just like with the previous one, once all the data is captured, we'll go through the exact same number of steps of processing, right? We'll erase unnecessary surfaces from the scans. We'll align our raw scans. We will position the frames very precisely against each other using global registration. Then we will fuse our data. We might need to filter out some noise afterwards, but not necessarily. After that, we'll simplify the mesh, import pictures and run photo registration, and finally apply texture to your model. For this project right here, for the sake of time saving, let's do a bit of a time leap and check the end result of the post-processing. So again, let's get back to my screen now. All right, here we go. So these are the 3 scans that we captured initially. So it was just enough to capture the entire geometry of the item and to create a highly detailed fusion. When the scans were aligned, all the unnecessary details were erased and everything were registered together, we got this, right? So this is that was the input for the fusion algorithm. Okay, and finally, when we fused it, when we run texture registration, when we apply texture, we got this. So this texture is what Micro has to offer, right? This is the texture from the original camera of the device. Again, it's pretty vibrant. You can still see all the details, all the small artifacts. It isn't half bad by any means. But then again, when you turn on the photo texturing, then you start noticing the difference. I think the biggest difference for this project is in the colors, right? So photo camera captures the original colors of the object, and we're capable of getting these exact tones, these exact colors on the final model. And also the resolution, the texture resolution is higher on the model on the right, which represents photo texturing. Let me show you another look. So again, model on the left, photo texturing, model on the right, micro. If you check the model itself closely, you will see that the model on the left represents the original colors of the model, while model on the right looks not as authentic. Okay. So again, let's have a few close-up shots. I'd like to remind you that this figurine is only about 50 millimeters high, so it's a fairly small item. All the geometrical details are here, and all the texture is here as well. Okay, so that is our second item. And now as I'm sharing my screen, let us get back to the project that my colleagues from Germany shared with us. Remember that armchair that they were photographing and scanning? So that is the armchair. Okay, let's give it a second for the texture to load up. Now we can check the geometry. Again, we were capturing with the Leo, so obviously there can be no issues with geometry whatsoever. If you don't know, right now we're using Artec Cloud, which is our new feature. And this is the final textured model. Okay, so we used Canon 7D for taking those pictures. Yeah, you can see the colors are really nice. And if we turn off the lighting, can actually improve it a little bit. Again, that's getting a bit ahead of myself. It's one of the tips that I will mention a bit later. But yeah, this is basically the armchair that you saw a couple of minutes ago during the video presentation of my colleagues that are currently in Germany. All right. Okay. So here through the Artec Cloud, I could share that project with my customers, with my colleagues, with anybody. I could download it onto my computer and keep working with it, or I could just keep processing the project right here in Artec Studio. That's depending on the kind of license that you have. So for this one, I will keep it as is. I'm not going to do anything to it. We just wanted to show you that you can be very mobile within the Artec environment, right? They scanned the project in Germany, and now we are able to see the results right here in Artec Cloud, and the texture looks really nice as well. Okay, now let's talk about some do's and don'ts of photo texturing. We've got quite a few, if I'm honest with you, so let me switch to my presentation. This is the very first slide, as you can tell. In some cases, your project will not require any relocation, but in others, the object will need to be repositioned to capture the geometry and texture entirely. This type of scenario brings in one very important change to your processing workflow. This change has to do with the features of the background and the fact that when we reposition the object, the photo texturing algorithm may rely on the features of the background instead of the features of the item itself, and therefore spoil your final texture. With that said, we have two options to make sure everything goes smoothly here. The first one is changing the background upon every repositioning. And the second, and arguably the more preferable one, is importing and registering photo sets of each position separately. So let me open up a project in Artec Studio real quick and show you what I'm talking about. So in that project, I have two scans, yeah, that represent two positions. And in that position, we scan the, let's say, the front part of that figurine, of the bird's figurine. And on the second raw scan, we captured the backside, yeah? So we have two scans, and we captured both scans on the same background. When we were doing that first scan, we also took the pictures, right? So we put it like this. We either started with scanning and then started taking pictures, or the other way around. It doesn't really matter. So all the pictures that we took in this session represent the very first photo shoot right here. So you can see that we've got two different, what do I call them? Elements in a workspace. I could actually rename it to Photos 1 and Photos 2 for the sake of it. Okay, so Photos 1 represent the first position of the item, and Photos 2 represent the second position of the item. So when I go about registration, what I do is first I process the project as is up until the fusion stage. I get my fusion, that fusion is simplified, and then I select the first scan, and here I've got the processed scan, the first scan. I select the fusion as well, and I select the first element, first photo folder. And I run photo registration for this set of items. Once it's done, I move on to the second scan to the second photo folder and to the same Fusion and run another photo registration, sorry. And when texturing the model, I select both of these photo elements in the workspace for texturing. So to sum everything up, when you need to reposition your item, here's what the processing workflow should look like. Put the object in the first position, scan it, take pictures of it. Then put the object in the second position, again, scan it, take pictures of it, and repeat for as many positions as needed. Then process your scans in Artec Studio just like you normally would. Run or erase everything you don't need, align your scans, run registration, fusion, simplification. Then import photos for each scanning position separately, meaning that you will have one photo set for each position of your object. After that, run photo registration for each position and each photo set separately, one by one. Then when applying texture, select all photo sets for texture source and do not select original scans for texture source. Okay, moving on to the second point. That was the first do, and here's the first don't. Please do not change the respective position of your object and the background between scanning and taking pictures in that particular position. We want the object to be scanned and photographed in the exact same state within one scanning session. If you think you touched the item after scanning and before taking pictures, it's better to rescan it to be 100% confident that the respective position of the texture frames of the object and that of the background is identical during both scanning and photographing processes. So again, the bottom line is, once you've done scanning, if you think you have touched the object before you took pictures of that object in that particular position, please rescan it, because the position of the item must be exactly identical during both scanning and taking pictures in that particular state, right? Because obviously then you will flip it over and you'll need to scan it again and take pictures again. Okay, that's it. The next thing is, please adjust the brightness of your scanner before scanning, and also play with the exposure settings of your camera to make sure that both texture frames of your scans and your photographs are of the adequate level of brightness. Our algorithm is kind of discriminative in this way, and it loves nice bright pictures. Right here, I wanted to demonstrate, pardon, I wanted to show you the example of the low level of brightness on both scanner texture frame and the camera frame, the camera picture, and the sufficient level of brightness on the texture frame and the photo that you took with the camera. Okay, so please do not hesitate to adjust brightness for both your scanner and your camera. Right, moving on to another thing. Another don't from us, okay, this is something that I have mentioned. Don't mix texture from an external source and the texture from a scanner. Like I said, we tried that multiple times and haven't identified any benefits to that. What you get normally is the original texture without much extra quality added by the external pictures. If you don't want to take our word for it, it's all right. Then go ahead and select both photos and original scans for texture source during scanning and see for yourself. Also, consider using a tripod. If you utilize a camera, an external camera, a DSLR camera, for example, try to use it with a tripod when possible. And also consider using a stabilizer when using a phone camera for texturing. The thing is, in case of high exposure time, it will help you to generate fewer blurry, unusable images. Sometimes it is not possible because of the shape of the object. It's got very rich geometry and you need to be able to take pictures from lots of different angles. You need to be able to be very flexible. In that case, it will barely help you. But if you change the exposure time, then now it probably makes a bit more sense to kind of stabilize your device so that you get better quality of your pictures. Okay, moving on to some advanced tips. So this one I have mentioned already to you a couple of minutes ago. We call it local texture improvement. Once the texture is applied, you can check it and and see if any part of it could use some improvement, right? Because normally you are aiming for very sharp and vibrant texture. If you think certain areas could use some improvement, you can add a few more detailed pictures of this area to improve texture. What's important here is that when we take these additional shots, we need to use the very same focal length, and yeah, it needs to be the same that's on the pictures that we took before. The thing about focal length, it has a certain depth to it. So when we take our first shots, we try to keep as many features in the depth of field, so we try to stay further away from the object. And for the close-up shots, we need to operate in the closest part of the depth of field so that the distance between the camera and the item is minimal. I would like to point out that when we add new pictures and import them into Artec Studio, we recommend re-importing the entire photo set and running photo registration for it as a whole. So old pictures plus new pictures. Photo sets that have already been registered once in Artec Studio should not be re-registered because the algorithm slightly modifies them, and the result of the repetitive photo registration of one same photo set may be unpredictable. Okay, we also noticed that some types of surfaces looked more natural and authentic when we turn off lighting in Artec Studio. So before you make your final judgment about the quality of your photo texture, try to turn off the lighting by pressing L on the keyboard. I will show you an example of that in a second. Sometimes you might need to scan something half transparent or extremely shiny, for that matter. Some of those objects have fantastic texture as well. Yeah, they have fantastic texture, and you might be wondering how to scan and apply color to them. As you know, scanning of transparent objects requires using some sort of dulling spray or talc powder. But if we cover the item with even a thin layer of powder, how do we capture the texture? There's a pretty simple workaround that works both for regular scanning and the photo texturing workflow. Let me quickly introduce to you that workflow in the context of applying externally taken pictures to a half translucent object that you can see on the screen right now. I call it a gem, but I'm not sure what the original name of this stone is. The core of our strategy here is to create separate scans for texture and geometry. Let's consider the situation when we don't need to reposition the object. So we'll only capture this side of it as the one that we see right now on the screen. The workflow starts with us putting the item on a texture-rich background and taking all the texture shots that we need. Then we have all those pictures, and now we will scan the object without applying any spray to it, which can be quite challenging given that we won't be able to use the majority of the surface for tracking. Our goal here is to maintain tracking at all costs and collect the texture information. Background as well as non-transparent parts of the item should be of great help here. Once this is done, we apply matting spray and scan the item the way we normally would. As you may have guessed, we will use this last scan for creating a fusion, and the first scan, or its texture frames in particular, as a bridge between photographs and the mesh. Okay. The processing workflow is fairly simple. First, we align and register our two scans. That's actually the trickiest part of the whole technique. When doing our first non-sprayed scan, we need to gather enough information about this scene so that this scan can be successfully registered with the sprayed one. If this checkbox is checked, the rest will fall into place very easily. So as we have connected the scans, we use the sprayed one for creating a fusion. Having done that, it's time to run photo registration with a pack of imported pictures. Yeah, no, the pack of imported pictures, fusion, and the first scan. Remember? The first one, the non-textured one. During texturing, we should exclude both scans from the texture source and only use the imported pictures. Okay, so that is basically the technique. We capture the object's texture first. We do not spray it. Then we take pictures of it. Then we apply spray. We scan it for geometry. We use that geometry scan for fusion, right? We get fusion from it. The most important part here is to acquire just enough features on our first scan, which is not sprayed, so that it can be aligned and registered with the second scan, which we scan for geometry. If that's done, then the rest is just a pretty straightforward, simple process. Let me actually segue into the next section of the event by showing you the result of this particular project. Okay, this one right here is the model that represents the texture of the space spider. Looks pretty interesting, a little bit of overexposure down there. The top part looks rather dark, but again, it's better than nothing. It's better than plain white, is what you get when you spray the item and then you scan it and apply that texture. But let me bring the photo texturing into the picture right here. So this is what we managed to acquire through the use of photo texturing. Again, as you can tell, it looks way more authentic than what the space spider has to offer. For this project, we applied 60 pictures onto that small item. These pictures were taken with a DSLR camera. So let me change the angle a couple of times so that you can see all the details. Okay. Right. Yeah, and if you look closely, you can see that all the overexposure is gone, and now we can actually see through it. And there is a lot of geometry and a lot of really nice fine texture behind all the overexposure. And the top part is just incredible, in my opinion. It looks great. Okay, the second thing that I'd like to show you is a fascinating painting. So this is what it looks like when scanned with EVA, when scanned and textured with EVA. Okay, so again, if that's the only model that you see, it looks really nice. You can see all the colors, they look amazing. The picture itself is absolutely gorgeous. It's a lovely picture. But then, let me select the photo texturing fusion and go to alignment menu so that I can jump from one to another. Okay, let me show you the general shot first. So this is the EVA texture, and this is the photo texturing texture. And I'd like to show you a few close-ups. So when I get closer to that photo textured picture, I can actually see every single stroke of the brush. All these fine texture details are now available. And again, if I switch back to the EVA texture, it looks plain, rather plain, and not as bright, as vibrant. So this version represents the original colors of the painting, and you can actually, if you look closer, you can zoom in to an extent that you can see the small cracks on the paint, right? Yeah, and see check all these brush strokes, all the paint. Looks amazing. Let me show you a few more areas right here. For example, let's select this one. Again, this is the EVA, and this is photo texturing. And by the way, since we used EVA HD, some of these brushstrokes are also represented by geometry. So when I select my fusion and I go to geometry mode, you can see that we can actually see all that paint as geometry as well. So it's not a plain picture, it's actually a volumetric one, and which makes it even more fascinating, doesn't it? Okay, so that is the second item that I wanted to show you. The third one is a face, so it's something that people from CGI might be interested in. So again, that was a bit of an experiment, really. So we decided to scan face of a person. This is Lena, a colleague of ours. First, we tried to scan it as is without applying any additional texture or anything like that. And a face doesn't really have that many of texture features. So we had to use some additional texture background. We put some texture features on the wall, and we asked Lena to sit right next to the wall, and that way we were able to successfully register all the texture frames. So yeah, this is what it looks like. I think it looks great. At a certain angle, it looks like a picture. You can't really tell the difference between a picture and this model. Well, hopefully Welcome doesn't spoil the quality too much so that you can appreciate all these fine texture features. All right, next up, we've got a figurine. If you're a gamer, you'll probably recognize this model right here. This is Ragnaros, and this is the texture from EVA. We scanned this object with EVA using the HD mode. Looks quite nice. But then again, let me bring in the photo texture. So let's begin with this part right here. I love this one the most. So this is what EVA has to offer. And then we switch to photo texturing. Yep. You can see all the transitions between these fine texture elements very clearly. It looks amazing. Again, under certain angles, it almost looks like a picture. And you can zoom into any area without losing any quality. You can see that every single texture feature has been reconstructed, texture has been applied to the model, and it's all right here. And also, if you look at the very bottom, we found some text here. This is what EVA's texture looks like. And then we switch to photo texturing. Looks much clearer. You can read every single letter down here. So yeah, let me give you another general view of the photo textured Ragnaros, and we'll move on to the second scene. So that's Ragnaros. Okay. Now the next model. Okay, this is one of my favorites again. So this one might be of particular interest on people that represents CGI industry and maybe forensic industry as well. So this is a goat skull, and this is what it looks like when you scan it and when you apply texture from the Leo. Again, doesn't look half bad. You can see all the texture elements. Geometry is great. The texture on the horns is amazing as well. So yeah, everything looks pretty good. But then you switch to the photo texture model. Boom. And now not only you can see all the tiny geometrical elements, you can also see every single crack on the skull. You can see every single dent or whatever that is. All the artifacts are now available. And also check out the horns. So this looks absolutely photorealistic. Okay, so this is what you can get on the skull. For this skull, we took 141 picture. And by the way, for the previous model, it was 158. And for Lena's face, it was 22. It was only 22 pictures. So for the skull, we took 141. We applied it. We scanned it with Leo using the HD mode again. Oh yeah, and I promised to show you the difference that lighting in Artec Studio makes. So for some of the models, you'll be able to get better results if you turn it off. So this is the model with the lighting turned off. Now, if I turn it on, it looks rather overexposed, so it doesn't look particularly impressive. So before making your final judgment on the quality of your texture, please turn the lighting off, and maybe you are working with a type of object that looks better with the lights off. Again, let's take another second to appreciate all these nice fine details of this object right here. I'd like to mention that for this project, we used the light box that you saw a couple of minutes ago. Yeah, we used a DSLR camera and the light box. So this is why this texture looks so impressive. Right, so next up, we've got something truly special. This is a crime scene, all right? So for this one, I do not have the Leo's texture. So everything that we see right now is photo texturing. This is an alleged crime scene, and you can see all these spills around the knife. You can see them very clearly. You can also zoom in and check the size of the bolster of the knife. You can see it, yeah, pretty well. All the details, looks great. So we decided to add this scene to kind of prove our point that you can also texture larger areas, right? You can not only apply texture to small models, but also you can apply to the stuff like this. And by the way, if you are curious about this case, it was successfully solved. The perpetrator was identified, arrested, and sentenced to cleaning all the SketchUp mess up. Okay, so I think that's going to be it for the model section. If you want to see more fascinating models, feel free to visit our website, artec3d.com. Under the Applications and 3D Scans tab, you can find a wide selection of 3D models sorted by the industries and the scanners that were used. You can also find our entire product line on the website. You can find the links to your local resellers and visit our technical support page. Okay, just like we promised before, as a follow-up to this event, to this workshop, we'll send you an email with a video recording of the event, the links to the models, to some of the models that we used for this workshop. And also, we will include a keynote document into the email that will outline everything that you need to know about the algorithm, about the photo texturing algorithm. We have more interesting stuff coming in the Artec events domain, so please stay tuned. Thank you very much for watching. The fact that you watched the whole thing gives me hope that you enjoyed the webinar and found it useful. This is not the only video of this kind on our channel, so feel free to explore our database and check some other stuff that you might be interested in. If you'd like to stay in the loop, please like this video and click subscribe to get access to our fresh content as soon as we release it. Thank you again for being with us, and bye for now.